Alright guys, so in section 3.3 we're going to be looking at slopes of lines and whether lines are parallel and perpendicular and reviewing lots of things you should remember from Algebra 1 last year. So hopefully this will be a review for you, but if you have any questions, just make sure you bring those into class and we can talk about them. So when we're thinking about slope, you learn what slope is in Algebra 1. There's lots of ways to describe slope. But the one thing you should remember is slope is my pen. So slope is going to be rise over run. So when we think about the graph of a line, so let's say I have a line. What we need to remember is rise is how far, say we've got this point here and here. So the rise is how far up I have to go, and then the run is how far over I have to go to get to the next point or to another point. So rise is also known as the change in y over the change in x. And then we also know slope is rate of change. So when we're talking about application problems, we want to know what the rate of change is, and that's typically describing the slope. So 4 types of slope we have. Obviously we have positive, we have negative, and then if I have a horizontal line, we know that the slope is 0. And then if we have a vertical line, we know the slope is undefined. So those are the 4 types of slope. So you should know why each of those would be positive, negative, 0, or undefined. So make sure you understand how you would get those. So to find the slope of the line that contains the given points, we're going to need to use the formula for slope. So remember, to find the slope between 2 given points, we use y2 minus y1, that's your change in y, over the change in x, x2 minus x1. So to work out a, we're going to have negative 5 minus negative 7 all over negative 2 minus 5. So that's how we would find the slope. So negative 5 minus negative 7, we got to remember minus the negative is a positive, so that's 2 over negative 7. So that tells us that if the slope is negative 2/7, then that line is going to fall to the right. So it's going to have negative slope. All right, for problem B. I don't know what just happened. Sorry about that. All right, so problem B. So same thing, y2 minus y1 over x2 minus x1. So 15 minus negative 2 over 6 minus 6. So we're going to have 17 over 0. Well, can we divide a number by 0? Is it possible to take something like 17 somethings and divide them into 0 parts? No, that's not possible. So this is where you have undefined slope. So do not leave the answer as 17 over 0. Leave it as undefined. All right, problem C. Same thing. y2 minus y1 over x2 minus x1. And if you need to go through and label these like x1, y1, x2, y2, go ahead. This is going to give us 0 over negative 18, which when we take 0 and divide it by a real number, that is going to be 0. So this would be a horizontal line. This would be a vertical line since it has undefined slope. So hopefully you remember that. Just come in with questions and bring them to class if you have any. Alright, so to find the slope of the graphs below, and all of these pictures, they're giving you 2 points. So we're going to use those 2 points to count. So if I start at J, then I can count, we're going to go up to where we're level with K and then over. So if I count, I got 1, 2, 3, 4, 5. So that's 5, 1, 2, 3, 4 over. So remember, it's change in Y over change in X, or rise over run, so that would be 5 over 4. So our slope is 5 over 4. Then for problem B, we're going to go down and then over. So we go down 1, 2, 3, 4, 5, 6. That would be negative 6 because I went down 6. And over 1, 2, 3, 4. So over 4. So our slope is negative 6 over 4. We always simplify our fractions when we're dealing with slopes, so that's actually negative 3 over 2. So that would be your slope for B. Alright, C is a horizontal line. So if we look, To go from N to P, there's no rise. So that would be 0. The run is over 1, 2, 3, 4, 5, 6, 7, which is 0. So here our slope is 0. I expect you to see a horizontal line and know the slope is 0. You shouldn't have to calculate it. So for an for a vertical line, we know the slope is undefined. So we just say M is undefined. And that's because we can count up 1, 2, 3, 4, 5, but we go over 0, which remember we said we can't take 5 of something and divide it into 0 parts, so that's undefined. So how do we determine if two lines are parallel, perpendicular, or neither? Now this symbol, hopefully you remember, means parallel. So if lines are parallel, you should remember they have the same slope. But if they have the same slope, we need to remember they would have a different y-intercept to be parallel. And you need to think about, why would the y-intercept need to be different? What would happen if it had the same slope and the same y-intercept? Alright, that symbol means perpendicular. So remember, their slopes are opposite reciprocals. So that means, for example, if I had a slope of -1/2, the slope perpendicular to that would be +2, because that would be 2 over 1. And then it doesn't matter if their y-intercepts are the same or not, as long as the slopes are opposite reciprocals. And then if it's neither, then neither of these things happen. They don't have the same slope, and they don't have opposite reciprocal slopes. So you should be able to look at equations and determine if they're parallel, perpendicular, or neither. So when we're working with lines, we're going to focus on the slope. So just based on these lines, we need to determine the slopes, and technically we want to know if they have different y-intercepts. So to find the slope of line 1, so we would have 19 minus -9, and then 8 minus -6. So 19 minus -9 is actually 28, and then 8 minus -6 is 14, which gives us a slope of 2. So then for line 2, we would have 0 minus -4, and 2 minus 0, which is 4 over 2, which is 2. So based on that, we would think that the lines should be parallel. So just based on this, the lines are parallel. Now, if we worked with line 1 and found that they both had the same y-intercept, then we would know that they are actually the same line. And that would mean coinciding, where they lay right on top of each other. So for now, we're going to say that they're parallel, since we have focused on the 5b. And bring that to class, and we'll go over it together. Alright, graph the line that satisfies each condition. So it's got to pass through -2, -5, and has to be parallel to the line that contains 1, 3, and 4, 5. So why did they tell us this part about being parallel to this line? Well, from that, we know that if two lines are parallel, they have the same slope, so we need to figure out the slope. So the slope of this line would be 5 minus 3 over 4 minus 1, because you're using x1, y1, x2, y2, which would be 2 over 3. So when I'm graphing this, I'm going to start at -2, -5, and then I've got to count the slope 2 over 3. So I'm going to go over -2, down 1, 2, 3, 4, 5. So I'm going to start right there. And then I've got to count up 2 and over 3. So my next point would be here. Up 2 over 3, next point's there, up 2 over 3, next point, up 2 over 3, next point. Remember, we can do the opposite in terms of signs also. So I can go down 2 and back -3, so the next point would be here, down 2, back -3, and the next point would be here. Your graphs need to go across the entire coordinate plane that you're given. So we would draw a line through those. And then make sure you have your arrows on the end of your line. So that's what it would look like. So I want you to try to figure out B, but remember this time we're dealing with a perpendicular. So it's perpendicular to that line FG. Alright, so for now, just bring those two problems in your notes. Don't worry about the assignment. We will work on it tomorrow in class. And if you have questions, please make sure you bring them, but hopefully this was a review for you. So I will see you in class.